They vary. You probably can't see very well, but the dot indicates the size of the plant roughly. The larger the dot, the larger the capacity. As you can see, the largest plants are in the largest areas such as La Habana and Santiago, Cuba. And likewise, the chlorination station density, darker green indicates larger density of chlorination station, and its inverse, as can be expected with the surface water treatment plant locations. Now, looking at the comparison between water demand and water treatment and distribution capacity. As mentioned, Cuba's population is about 11 million. Overall demand, total, that's agriculture, industrial, and domestic, is about 1.77 cubic meters per person per day. The majority of this, can be expected, is agricultural. For watering plants, for a number of things. This water is not treated, rather it is extracted from the ground and supplied for the agricultural industry. The remaining amount is treated for the most part, domestic and industrial. And there's a total domestic demand, estimated demand of 0.34 cubic meters per person per day, or 340 liters per person per day. Now, when we look at the capacity side of the equation, we see that there's approximately that much capacity for water treatment. On the surface of it, it would seem that Cuba has enough water treatment capacity to meet its potable water needs, at least on a domestic level. But unfortunately, that's not the case. And as Dr. Donoso alluded to, a lot of it has to do with piping. The distribution system is in quite bad shape. In Cuba, there's approximately 19,000 kilometers of water mains or water distribution network and 2,000 pump stations. Admittedly, even the Cuban government has stated that over 50% of water is lost, likely even more. So of that 0.36 cubic meters per person per day of water treatment capacity based on the plants, only half of that, maybe 0.18 cubic meters per person per day, are actually available for the population. So clearly, the result is that available potable water is not equal to potable water demand. People in Cuba do not have access to clean, sanitized potable water. What are some things that can be done? One priority would be to repair the distribution system. Apparently, there's more capacity, and more treatment capacity than there is than is being taken advantage of at this moment. So repairing the existing distribution system would be priority number one. This can be done in the future using various methods, most notably trenchless technology to avoid disruptions to everyday life. Trenchless technology is basically the removal and replacement of piping without having to open up a roadway or digging up the pipe, rather underground methods that are not as invasive. Another priority would be to rehabilitate and upgrade the existing water pump stations. Without the pump stations, you cannot move potable water from a plant to the end user. So priority number two, once the pipes are repaired, would be to go back and improve the pumping systems to make sure that there's adequate conveyance of water. And an equal priority would be disinfection. Currently, there's not an adequate supply of chlorine gas on the island. In the future, we think it would be recommendable for Cuba to consider the installation of on-site sodium hypochlorite generation systems to disinfect water, especially groundwater, on-site. That way, not rely on purchasing chlorine gas, transporting chlorine gas, etc. The disinfectant would be available at the site of use. And this is an order of magnitude cost estimate using data from other developing countries and countries specifically in Latin America. Just a ballpark number for high priority improvements in the future. This number obviously is subject to change based on many factors. The total cost or estimated cost for water system improvements amount to about $3.5 billion US dollars. Now looking at the wastewater side, sanitation, as Dr. Duani mentioned, things like cholera didn't exist in Cuba for many, many years, and now we're seeing it, and that has much to do with inadequate sanitation. Cuba claims that their estimated sanitary coverage is about 94%. That's according to PAHO. But that includes in situ wastewater systems, or latrines, septic tanks, outhouses, things of that nature. So in reality, only 38% of Cubans have access or are connected to the sanitary sewer system. That's a very low number. In 2007, a publication by Belt and Velasquez estimated that only 4% of that 38% of individuals who are connected to the sanitary sewer system, only 4% of that flow is treated before being discharged to a river or to the environment, essentially. There are a total of 11, just 11 existing wastewater treatment plants on the island. 3, and the largest of these, are located in the city of Havana. Outside Havana, there are essentially no plants. Really, the only plants that are present outside Havana are in the tourist areas, such as Varadero and the Keys to the north. Of these 11 plants, only 3 are suspected to be operational at this moment. The good news is that there is some work planned. There are currently six future wastewater treatment plants in the works. These are pretty much all within Havana in an effort to improve the quality of the Armendariz River. 2 are in the Armendariz River Basin and 4 on the Luyano and Martin Perez rivers. 3 of these 6 have begun construction but have been delayed. Actually, they began construction in the middle of the 2000s, but hurricanes and things of that nature have delayed construction, and it's our understanding, the study was done like in 2010, so it's our understanding that they still haven't been completed, and 3 are in the planning stages. Funding has come from the United Nations Development Program and from Kuwait, among others. This is a map showing the location of these treatment plants within the city of Havana, existing and proposed. For example, the Maria del Carmen wastewater treatment plant is shown on the Luyano River, and a couple other, like the Petire wastewater treatment plant, are also indicated. And these are the other wastewater treatment plants that are present on the island. As you can see, they're all either in Havana or to the north. The ones in the north are very small, as they only treat hotels and essentially tourist areas. What's the result of this lack of sanitation? Well, essentially, Cuba generates approximately 3 million cubic meters per day, or 270 liters per person per day, of wastewater, of black water. Most of this water, as can be expected, is generated in the cities and urban areas, 76% versus 24% rural. If we were to look at the capacity to treat this water currently, we would essentially see about 21,000 cubic meters per day, or less than 1% of the wastewater generated, could be treated with today's infrastructure. Looking into the future, taking into account that there are several plants proposed, in an ideal future there will be about 400,000 cubic meters per day of capacity. So if all plants were operational in Cuba, current plants, and all proposed plants were built and operating, about 15% of Cuba's wastewater flows would be treated. So 85% would still be discharged to the environment in one way or another. To remedy this situation, we have suggested several high priority improvements. In the wastewater, unlike water, there's not a whole lot of existing infrastructure. Most of the sewers are 100 years old, and in Havana and in other cities, elsewhere there are no sewers. So priority number 1 in the future Cuba would be the building out of the collection systems to collect sanitary sewer from Cuba's residents. The next priority would be pump stations to be able to transport that wastewater from the collection system to an eventual wastewater treatment plant, and eventually in the future build a wastewater treatment plant in at least the metro areas. Priority should be given, obviously, to protecting source water quality to ensure public health. And really, since funding is always limited and resources are limited, emphasis should be placed on highly populated areas, those greater than 100,000 people or so. The overall cost of wastewater improvements, only focusing, high priority improvements to bring the system up to a basic level of service, and only within the urban areas of greater than 100,000 population, would be approximately $2.2 billion. That's our order of magnitude estimate. And that brings us to a total for the water and the wastewater of approximately $6 billion for high priority improvements to bring the system up to a basic level of service. In conclusion, I think as we could all deduce, Cuba's water and wastewater infrastructure warrants extensive improvements. It is very important in terms of public health to improve the water distribution system, to contain the losses and make sure that Cubans can have safe drinking water. They require a nationwide chlorination system, but really a nationwide on-site hypochlorite generation system to ensure that groundwater extracted is also disinfected. Rehabilitation of existing wastewater infrastructure is very needed, is extremely important. And the construction of new wastewater infrastructure to protect rivers and watersheds and protect human health is also highly recommended. I look forward to your questions later.
Thank you so very much, Mr. Cueto. We're going to give Dr. Takiev the opportunity to make some short remarks. I have to say that Dr. Takiev found out that he was going to be in my panel this morning, and so he has had a very short time to prepare his remarks.
Well, thank you, Ines, and thank you, everybody, the participants in this meeting. It's an honor to be here and to be able to discuss various aspects of the water resources and hydrology in Cuba. And my colleagues have presented a very interesting statistics about the island and about the water use, the water balance. So my focus will be mostly on what are typical needs in order to be able to successfully manage watersheds and hydrology, and to ensure that there is sufficient amount of high quality, clean water for everybody, free of any contaminants or any bacterial diseases. And this is a challenge not just for Cuba, but for each of the islands. And just from a hydrological point of view, Cuba has an elongated shape, and it has inland hydrology that's very much coupled with the coastal. So when we discuss the hydrology, we have to keep in mind that we need to look in the inland hydrology, how is it coupled with the coastal hydrology, and then we have to look at the water quality, inland water quality, and relation with the water quality of the coastal areas. Typically, hydrological studies, we discuss the watersheds. Watershed is the unit where all the water, all the rainfall water flows into the watershed, and typically we do analysis per watershed. And there is, the watersheds can be divided into multiple degrees of catchment, which is contained in watershed, and river basins. River basins are pretty much the largest unit that hydrologists and water resources engineers analyze. And I will just discuss with you the scientific needs of how this analysis is being conducted. In general, one of the most important aspects to understand the hydrology of a river basin is to know the topography. And Maria mentioned about the needs of the topography, and because that's what defines how the water flows within the watershed, how fast it goes between different areas, and whether you have flooding, whether you have lack of water in some of the areas, and this is very much defined by the topography. Topography is a challenge, and it's a challenge not only for Cuba but for many islands. It requires survey. Until maybe like 10-20 years ago, survey has been done manually, which means a group of surveyors with highly accurate instruments go into the watershed and determine basic points, and then interpolate and to understand, to receive a surface, a three-dimensional surface, which is then used for analysis, any analysis within the watershed. And recently, this analysis is being done through LiDAR. LiDAR is a laser system that's attached to an airplane. Airplane flies, and just based on the reflection of the laser, you can determine the topography. This is a highly accurate methodology, and it's very fast, and it provides data, very intense grid data. In general, this type of, not everybody has access to wider collected data, and these are expensive data collection events. However, these are one of the most important components into the hydrological and water resource analysis. And that's the starting point for any analysis of the river basin. In terms of water resources, availability throughout the basin, potential flooding possibilities, and that's pretty much the starting point. Additional information is needed about the soils, because soils determine how much of this water that falls on the ground infiltrates into the watershed. And infiltration is a particularly important aspect, because islands are not connected, they're surrounded by the sea. So the higher infiltration you have, the higher storage you have in the subsurface, and typically a lens is formed where the fresh water sits on the top of the salt water. And for islands, it's particularly important not to over-abstract water, not to withdraw more water than is available, because then you lose that lens under the surface. And Cuba is a much greater island, so it has much higher buffering capacities in terms of aspect, but nevertheless this is an important aspect. And that's another type of data that's required. In addition, data about the vegetation is needed, because the vegetation is the component that determines how much of the water evaporates through the leaves, and it also manages how much water is going to be abstracted from the subsurface through the roots, and it's a very important component, especially for a tropical area. And in addition, we need to look at what the current infrastructure is, and how what are the drainage structures within the basin,